Give it up for our next headlight talk.
So I'm Rituraj, and then I'm happy to be back in Hyderabad after almost 1 year. I was working with one of the companies in Hyderabad. And today's topic is quite interesting. It's Neuro UX and AI turning brain waves into ultimate user happiness. Thanks to UX India 2025 for providing me this wonderful opportunity to be here and do a little bit of knowledge sharing over 18 minutes. This is me. I love to do research and development, consulting, advisory, coaching, mentoring, training, teaching, facilitation. I love to play with products, be it tangible, intangible products, SaaS, B2B, B2C, any kind of products. I've worked with so many global MNCs into product as well as service uh, genre. And yeah, you can grab a copy of that book, which is 5 years old, but it is one of the Amazon best sellers. I'm writing another one in AI product management space, and I do have 3 design patents on my name out of those 8 patents. Okay, and in my free time, I like to write a lot on LinkedIn. I like to play tabla. I'm playing it since the age of 6. I like to do karaoke singing, and soccer is my passion. Okay? This is pretty much about me. A quick disclaimer, there are 3 of them. None of the opinions, perspectives, viewpoints, whichever I'm going to talk to, they belong to the organization where I work. I might be calling out some technologies, products, use cases. I'm not endorsing them. I might have personally used them, or my teams might have used them. So it's not at all a marketing or sales geek. And the topic is vast, okay? It's difficult to cover everything in 18 minutes, but feel free to agree to disagree. And if you have any thoughts, concerns, questions, doubts, please feel free to get in touch with me after this talk. This is happening right now, right? Generative AI is helping UX professionals, be it content, edition, research, analysis, ideation, partnership, design assistance. Massive 6.40 billion growth in 2025 when it comes to UX services market globally. 2032, 2.07 billions of dollars. That is what UI UX design software market is plunging into. Generative AI in UX is projected to grow from $741 million in 2024 to $13.94 billion by 2034. These are few fact checks which I would like to give it to you before I dive into the actual topic. Figma remains go-to UI UX platform despite vibe coding tools are there. Shopify just killed UX design is what we have been hearing since quite a couple of months. And in the bank of future, UX beats AI. Key fintech tips from NetGuru descriptions, Forum with N26 and Solaris Bank. Those are the 2 digital banks which are mainly operating in Europe, right? There is a disruption happening there. AI is coming for your graphic design job. Netflix brings in AI for UX and homepage update. Graphic designer shares why AI has ruined 24 years worth experience. So on both the sides, you get to see different perspectives. And I enjoyed my nano banana moment with these 2 guys. Nano banana, how many of you have heard about it, right? So it's all happening, right? Few positive things. I won't call it as negative things, but things which might trouble in near future when it comes to AI. Are you tired of guessing what makes your users smile? My teams, they are tired of. I have listened to the UX researchers, UX designers. Some of them are sitting right here. They are from one of the past organizations. And the ultimate thing is nothing but they have a frustration to understand why a certain user experience behavior is like that. Okay? Why something is like that, what they are seeing. We have confused users, we have abandoned carts, we have furrowed brows, and then ultimately, as UX people, we always think about what our users are really thinking, right? And it's always about some kind of guesswork. Even though you have your design thinking and design sprints and user research and all of that, sometimes a bouncer comes and then everything goes on a toss, right? There is a solution to it, okay? And the solution is nothing but analyzing brainwave patterns of your end users and using AI to further predict some outcomes out of those patterns. And there comes this topic called as Neuro UX and AI, where you have some raw data and then the translation happens in between the correlation of these two technologies. Have you seen anything like this before? You know ECG, electronic cardiogram, they put some jelly on your chest, side chest, and then they put some rubber uh, uh, balls, and then they read through your heart signals, right? And then you get to see your heartbeat. That is for your heart. Similarly, there is a terminology called as EEG, electro, electro, exactly, yes? Yes. So EEG is something using which you can monitor the brainwave patterns. And there are devices available into the market. If you look at the Indian market, you can get a device at bare minimum 4,000 rupees, and then it ranges up to 6 lakh rupees. Okay? Using this device, you can understand what kind of excitement, frustration, and engagement is happening whenever a user is looking into any kind of UI. Okay? And then comes this particular analogy, a high level architecture. I don't want to get into too much of tech oriented things. That particular EEG headset, what you have seen just now, it gathers the data, does the data processing. Further, we can give it to AI analysis and metrics generation. Using some machine learning algorithms, you can analyze the data which is coming in from millions of users, probably billions of users. The more the data you have, your hypothesis becomes valid, right? There might be certain outliers also here and there. And then you also get into real-time visualization. You can use that data, give it to the machine learning model. You can build some reports. You can predict something out of it. You basically monitor the user actions through some screen recording. So you acquire the data, you process the data, analyze it, and then you need to have some kind of UX research platform and tool which will help you to do all of that. And this is how it works. Okay? So if you look at the tech side of things, you have a platform or a framework called as Unity and NeuroPipe, which sits on to your one PC. It reads the visual and auditory output by looking at the eye tracking of your users. And then on the other side, you have a brain vision, which is sitting onto the PC number 2, which is another platform. And there is a protocol which is called as LSL, Lab Streaming Layer, which helps you to bring that data from PC2 to PC1. And then all that data gets wirelessly transmitted through the analysis of your brain waves. Okay? The AI translator, applied example of UX measurement on mobile screens with the help of EEG. You might have understood which particular mobile app I'm showcasing you here, right? The user is trying to buy a mobile phone and look at the eye movement of the user. Typically, they are looking at the pricing, ratings, uh, the free delivery by which particular date, right? So those are nothing but the hot points where the user is continuously paying an attention. And this is the data which you are getting it from that device, which I have showed it to you on the previous slide. And these are nothing but the brainwave patterns. Brain has 86 billion neurons. The concept of artificial neural network has been also derived based upon human brain. Okay? And then the brain waves go into 5 patterns. Those patterns are D, T, A, B, G, delta, theta, alpha, beta, and gamma. Whenever you are into deep sleep, you are relaxed, you are into the delta state. And then in opposite to that, the extreme opposite to that is nothing but gamma state, where you are excited, the cognitive load is much more than expected. So wherever you get to see a red color, that is where the brainwave type is gamma. The green one is nothing but delta. So with this particular framework, integration, a little bit of using some of the production platforms, all that integration gave us something like this, and it's a real-time case study, okay? 100% of the users are equipped with a brain. We all have brain. User experience is a series of electrochemical activities that occur within the brain. 95% of user behavior is completely unconscious. 97% of what users see on a screen is always blurry. Okay, it's a hypothesis which we could test, and this is the result of that particular hypothesis. It's an outcome. And 80% of user behavior is conditioned by the limbic system, which favors behaviors that generate rewards. Dopamine generation, once you have Red Bull, dopamine shoots up, right? So it also avoids behaviors that generate unpleasantness. So this is what the theory says, this is what the practical implementation says, which we could do in one of my previous teams setup, okay? And then, of course, we were looking into the retail, e-commerce, and supply chain customers. That was the domain in which we were analyzing all of that. We were struggling a bit with the dashboards which we used to create for our sales teams, operations teams, even engineering teams. So there is a concept called as developer productivity engineering, where engineering teams can monitor how effective, efficient, and productive they are. Okay, so they created some Grafana dashboards, and then we applied this particular framework to change the cognitive load to a better shaped, delta-oriented brainwave pattern, right? Where we could get to see some difference. And this is where the experiment happened, where we wanted to peek into the brain's processing of complexity. So we could look into the alpha waves, we could look into the theta waves based upon the cognitive load, click frequency, different parameters, attention, engagement, excitement, and all of that. We could convert those messy, chaotic, and complicated dashboards to something like this, and to something like this. And the ultimate result which we could see in terms of brain waves was something like this. We could move from this to that. And it was an outcome of that easy experimentation, what we could do. And then over the period of 2 years, we could give all of that data to a machine learning model to predict something meaningful out of it. And then that particular dashboard, the two dashboard which I just showed it to you, those engineering teams were globally distributed teams. So people coming out from different cultures, different backgrounds, different technical skill sets, different experiences, they treated the visualization of dashboards altogether differently. And this analysis really helped us to come to one standard definition or a single source of truth kind of a visualization for their own dashboards. The future is bright and wavy, where while doing all of this, we need to always consider the user consent, GDPR, there might be some PII data which is getting used into all such kind of experimentations. So we need to get their consent, we need to take care of the data privacy, data safety, right? Whichever frameworks which we are using, we need to ensure that is not adding any kind of hallucinations, cognitive biases, right? The nano banana thingy, right? Which is something which talks about deep fake problem of generative AI, right? So all of that, we always need to remember and take care of all of it in advance. Otherwise, the model might predict something different. And then if bias is there, you're not going to get to that particular happy brainwave experience, user experience. And the path forward is nothing but I want you all to play with such kind of devices to get to know what kind of brainwave patterns you get to see in your particular domains, in your particular products, right? To correlate certain things. And then I could do that across 3 to 4 domains, and then we could see some common patterns. The moment the UI becomes messy, the UI becomes a little bit of chaotic, the users are going to end up into the brainwave pattern, which is going to kill the user experience, right? So connecting the dots, you can define your own process. Those are just some of the sample frameworks which we could use. There are some open source frameworks also which are available into the market, which you can go and use for free, okay? And then you can experiment it out on your own. That's it for today. I think 18 minutes is something where I could show you something like that. It's just a snippet of the big experimentation which we could do over the period of 2 years. Thank you.